All right, Steve, so tell us a little bit about what we have going on here on the dyno, and how do you ensure kind of the repeatability of your dyno pulls?
Well, we do the repeatability as we try to keep everything within about a 10-degree window of temperature. Oil temperature, we have a heater right here. We also have this tube here. This helps us when we have dry sumps on here, seeing if we have any kind of dry sump problem or making a pull. If it's putting oil in the motor and it's not scavenging it out, we'll see the oil level line come down as we're running it. Also, if you have a breather problem or something like that and there's a pressure differential in there, you'll also see this do weird stuff, so we can make sure we don't have any dry sump issue. We also have like a 2,000 watt water heater back here on our column, and we also see we got insulation up on it. We fight really, really hard to keep water temperature and oil temperature in these motors throughout the day. Most guys, they run the motors too cold, and they actually usually have overheating problems in the dyno, but they run them, and because of that, they run them colder. So they run them, you'll see a lot of dyno sheets that have 120s, 130, 140 degree water temp on the poles. We run our stuff 180, 190. If that's the window that we're going to run that in the track, we run it there. If our window's 190 to 200, we'll run our motors 190 to 200 on all the poles. It's a scientific experiment. The less variables we have, the more accurate each of our poles is by not having so many variables.
And the closer that you're keeping it to what the car would actually see in competition.
So we want to have that tune. We don't need a tune for this motor at 120 degree water temperature. That tune doesn't do us any good. Doesn't do us any good at 140 degree water temperature. The motor will never run that on the track. So, and the tunes are very particular about that. A couple of the things that we do here, we have one of these filter mags on the filter here. Those things are awesome. Everybody that's ever had one of those and been in dyno with us and seen what this does, take the filter and cut it apart, and seen all the ferrous materials that it picks up off the filter that the filter does not have to deal with. So anything steel or iron, this sucks it all the way across the filter, and the filter medium, that filter does not have to deal with any of the ferrous metals. These things are awesome.
I think we'll take a look at that later. You'll probably cut one of these filters open
Yes.
after a dyno pull?
Yes, we always cut those open. We'll probably go through about 3 or 4 filters on this motor throughout the day. We're constantly keeping track of that, making sure everything's happy and hunky-dory. We also change oil in this thing after making a few pulls on it, and we'll have fresh oil in it. Sometimes we'll change oil another time during the day too if we feel like we need to, or we want to look at something.
So let's talk a little bit about, this is a methanol engine, right? It runs on methanol.
It's methanol, mechanical fuel injection, so it's a constant flow system with bypasses.
And so that's how you tune, with that bypass, that's how you tune for making the power that you're making.
Our fuel curve all works on how much fuel do we return to the tank.
How much you bleed off.
Whatever we don't return to the tank goes to the motor.
Okay.
Kind of works a little backwards the way you think about most fuel systems.
Unlike a carburetor where you try, you up the jet size to add fuel to it.
Right. Us, a bigger pill going to the back would allow more fuel going to the back. With less fuel in the motor, that's leaning the motor out.
Okay.
So it kind of works backwards from. We also deal with pressures on these things. Pressure's a huge deal with mechanical fuel injection because we're running 60, 70, 80, 110, 140 psi in our fuel systems, and that changes because the pump is driven by the engine. So the faster the engine turns, the faster the pump turns, so it has more volume and more pressure ability. So that adds another dynamic to the whole fuel system, which is a good thing and a bad thing at the same time.
So you could go out there and you could make one number, say at 7,000 RPM, think you're good, you turn the thing up to 8,500, all of a sudden maybe you got a fuel delivery problem.
Or you have way too much fuel.
Too much.
Usually the thing, they get fat on the top side because volumetric efficiency falls down on the motor. We can only get so much air into it, so we get up to 8,000 RPM and starts running out of air. We can only get so much air, so our air requirement goes down. When our air requirement goes down, our fuel requirement goes down. Yet our pump is turning faster and able to supply more fuel.
So you got to start bleeding off more.
We got to start bleeding. That's why we have a high-speed bypass. So we have one that comes in, usually past peak horsepower or someplace right around there, and it starts bleeding off fuel right after peak horsepower, so that we can keep our after peak horsepower up.
Yeah.
We don't have as much fall off. We want to try to keep that going out as far as
that gives you a competitive advantage at the top end of the straightaway going into the next corner, right?
We do so many motors here that when we get done with them, past peak, we'll have 120 more horsepower than most people have. And that's the motor when you go down the straightaway and all of a sudden you see a car just jump out and just take off to the straightaway. You're like, holy cow, that thing like hit like the nitrous oxide button. Well, that's just that we're not losing the 120 horsepower. Everybody else is losing.
That's fuel management.
That is fuel management.
And you only learn that from dynoing these things and figuring out what it is that they need, what do they want, and continuing to fine-tune that tune-up.
That is why you dyno these motors. You should dyno any motor, but sprint car motors and mechanical fuel injection is very, very important. You'll never get to the numbers. I've always said it. I talk about my website. I feel like everybody out here with one of these is giving up 10% horsepower to too fat a tune, too much fuel.
Now,
On a 700 horsepower motor that's throwing away 70 horsepower that you paid good money for, that's out the window and you don't get to keep it.